Hello, my name is Muhammad Al-Zubi and I'm taking Internet of Things here at UAB. The issue is my washer doesn't make a lot enough noise when it finishes the cycle, so if I'm in a different part of the house, I won't hear it when it's done, and if I'm close enough, I still don't realize that it's done because after many years of hearing the same noise over and over, my brain's tuned it out. Now, many modern washers, they're smart, so they have apps that will tell you when the cycle's done using Wi-Fi. Unfortunately, my washer does not have any Wi-Fi capabilities, and so I would have to make some kind of external monitoring system that's connected to a cloud service so that I will be able to see when the washer's done in some kind of app.
So here you can see both door status and complete status are false, but then when the sound is played from the phone, the X is gonna change into a check mark that's complete. So here you can see me simulating the door being open with a water sprayer, and humidity sensor takes a couple of seconds before it makes measurements, so it's gonna take a bit, and there we go, it changed to true that the door is open and it recorded both times.
Another feature I had is that the user will be able to select the cycle mode they had put the washer on, so that way before the cycle finished, they can be able to tell the predicted time that the washer will finish. For example, if the current time is 12 o'clock and they select delicate, which takes 30 minutes, let's say, then it will tell them that the complete time is going to be 12:30. That's its predicted time by the manufacturer. That way, you can really see how long a cycle is going to take compared to the manufacturer time. So if the washer says a delicate cycle takes 30 minutes, and then the Arduino ends up measuring the cycle to take, like, let's say 35 minutes, then you can know exactly how long a cycle takes compared to the manufacturer reported time. Because we all know when a washer is taking so long, it keeps on saying 1 minute left, 1 minute left. That way you can know the true value and you can really see how long a cycle takes, which I think is interesting.
You can see here I'm switching between the different cycle modes, and it's actually updating the predicted time without going up or down. It's not changing, and this value will obviously update to the real time that it's complete. Once it actually does complete, this value will go away and the real value will replace it.
So one of the challenges I faced with this project was in the code when I was trying to calculate the predicted complete time, which is when they're selecting one of these cycle modes. They should be able to see the predicted time based on the times that are reported on the washer, 45 minutes, 30 minutes, 15 minutes, whatever. And what was happening is the predicted complete time should be the start of the cycle, that time, plus the time that it takes to run the cycle. But what was happening is start time is a global variable set up here, and I would set it to the local time with this built-in Arduino command, and it would interpret it as 12:45 or 12:46 or 12:47 or whenever they click the button. And then down here in this function, it would just interpret start time to be 0. Even though start time is a global variable, it could just never access that value. So what I had to do is get rid of this whole variable and just use the Arduino command down here in the function instead of having it outside the function up here. But then what was happening is every time the user would click the button, it would just increase without bound. It would increase 12:45, 12:46, 12:47, 12:48, so it would be as if the cycle never finishes. So what I then had to do finally is subtract some kind of offset value, so that way it would just stay at 12:45. It wouldn't just keep on going up. So the offset value is just going to be how long the Arduino has been running. So it would be current time plus cycle time minus the offset of how long the Arduino has been running. So here's an example. Let's say the true start time of the cycle was 12 p.m. Then let's say the user waits 5 minutes and then they click normal. So they click the button at 12:05. So here the local time is going to be 12:05. Then it's going to add 45 minutes for how long the cycle takes, and it's going to equal 12:50. Well, no, that's wrong, because the cycle started at 12 p.m. so it should end 12:45, not 12:50, 5 minutes after when the user clicked the button. So what we do is we just subtract that the 5 minutes that the Arduino has already been running, and then it's going to equal the true time. So then we get the true value, and the predicted time won't just go up without bound.